Hi friends, welcome back to my channel. For the people who have already subscribed my channel and for the people who have recently found my channel, a hearty welcome to this channel. I am Yashwardhan. Now, before I go into the topic, let me introduce myself. I am Yashwardhan to the people who are new to this channel. I am Yashwardhan, an electronic enthusiastic and electronic engineer who likes to experiment with different electronic circuits as well as the Arduino boards and the development boards in general, and make videos explaining the concepts which I know. Now, the topic of this video is nothing but how we are going to write a VHDL code in Vivado software and how we are going to realize it. Now, this Vivado software you can easily get from your lab admins, or you can easily go to the you can directly go Google it and you can get the software. It is a little bit bulky software, but it's a very good software which is used in most of the industry also. Now the topic, now friends, let me clarify one thing. In this video I am going to be going about how we are going to design it in the software version, and I am not going to touch the hardware part. In general, whenever we are designing anything in VHDL, we generally implemented that on a Fpga board. What is an Fpga board? I make a detailed video it in the future, but for basic understanding, it is nothing but it is just a blank slate which has all the components, but they are not defined. We are writing the VHDL code or a Verilog code or a hardware description language code in order to define what is the hardware, and then we can also define the application software. In this technique is mostly used in the VLSI domain as well as in the electronic system domain, where we want to check the circuits. Now with that out of the way, let us move on to the topic of understanding how we are going to design a circuit. So first of all, you need to double click on the Vivado software icon that will be available. Based on your system process speed, it takes some time for the Vivado software to generate. Let's wait for some time. First of all, you get an indication like this. Yeah. Now friends, this is the main this is the screen you will observe once the Vivado software is fully loaded. Here, as I have already experimented with some projects, you can see a list of the recent projects which I have tested. But if you are new to this topic, if you are new to this and you are currently doing a first project, this recent project will be fully empty and you get only this part. That is, you have a quick start where you have the create option. Now let us go quickly around this. Here first is the create project, which we use to create a project, and then we have an open project. That is, if you have already created a project, you can just open that project and understand it, and you can see some example projects also. And these managing IP, open hardware, these will come a little bit earlier. So first let us understand how we are going to create this project. First of all, you need to click on create project. Then a window like this will appear. It will just show you the different steps which we need to follow. Okay, just click next. Next, it will ask the location where you want to, it will ask the project name as well as the location where you want to store your project. Just select the whatever the location you want, you can select. For safety purpose, I am blurring this, and you can give some project name as, let's say, example 1, let me say, and just click next. Then here you get you need to select the project type. By default, whenever we are just writing the VHDL code and you are just testing it, you can just select RTL project. Here we create everything and we run the synthesis. If you are only using only for implementation purpose, then you need to select this. If you are doing this in order to check how you are going to, what input and what output, you can just select the repair. Or if you are importing a project from other thing, you can just get imported project and you can create an example project also. Then click next. Next it will ask the sources. You can add your source file now itself, or you can add it once you have started the thing. But one thing is that before you move next, select the target language as VHDL. By default, the target language can either be in VHDL or in Verilog. You can just select it as VHDL and click next. Then you need to add the constraint file. These constraint files are nothing but the additional files which are required in order to accurately predict our results. Here we generally add the file of the hardware in indicating which are the outputs, which are the inputs, and what pins are linked to it. I will tell you a little bit later. And then click next. Then it will ask the part number. Here I will be using the board which is available in my microcontroller lab. Whatever the board that is available with you, or in your college lab, you can use it. My board is XC7800T CESG 324. Mostly in almost all the institutes that are available in India, mostly all the institutes we use this Nexus 4 Fpga board only. So this is the part number of that is 324. Okay, sorry. Yeah, CSG. Oh, sorry. CS then G then 324_1. This is the part number. Here you can see how many input and output ports are available in this particular IC, how many IOBs, which is nothing but a kind of thing. Then you have the how many LED, you can see how many flip-flops are available, and etc. And just click next. Next it will show you the detailed summary of different components. Just click finish. Once you click finish, the system will start initializing the project and will open the thing. Yeah, this is the screen that will be open for you. Before we move forward, let us understand what are the different parts of this screen. Then we move forward. Here to the left hand side, whatever the thing is there, this is called the flow navigator. Why it is called the flow navigator is because it has all the components, all the steps that we need to follow in order to design a circuit lined up correctly. At present, as we are just writing the code and you are checking this, you will be requiring from simulation to the last. Okay? Yeah. Next we have the source folder. Here we will be adding a source files, constraint files, etc. Then we have the properties folder to see, and this is a debugging design folder, log, reports you can see, and this is just a project summary. Here you can see that your project name, your project location, then what family your IC belongs to, then the project part number, then you have what is the top module. Top module is nothing but it is the main it is the, let's say it is the main circuit that you will be defining. Then you will be defining your target language and mixed. You can see all the details just by scrolling it. You can see everything. Okay, now let's go. Now let us first add a design source. To do that, just go to sources, right click on the design sources and click add sources, or you can use the shortcut key Alt plus capital A. Now then it will ask whether you want to add a constraint source or a design source or a simulation source. What do we want to add? We want to add a design source. So just click add or create a design source and click next. Now friends, once you click next, a window like this will appear. Here you will have option. You can add your directories, you can add files, or you can create a file. As we doesn't have any code or previous editor, we need to add the file. Just click on create file. Then first you need to select what type of file type you will be using. That is, if you are writing a code in VHDL, you can just say VHDL. If you are writing it in system Verilog, you can click system Verilog. If you are writing in Verilog, you can click very long and click. I will be writing in VHDL, so let's say VHDL. Then I need to give a file name to this, that is the code name. Let us okay, for basic understanding, let us take a simple circuit like a half adder. Okay, half adder. Friends, if you are at this point, mostly if you know the half adder, it's a good. If you don't know, so I'll give you a basic gist, and I have explained it in a future video about what is a half adder, how you'll be realizing it. Just to give you a gist, and half adder is a simple circuit which is adding two 1-bit numbers. That is, you have A is a 1-bit number and B is another 1-bit number. You are just adding them and you are generating the sum and carry, and just click OK. Okay. Yeah, this is the thing. Then just click finish. Once you click finish, it will just it will be going on adding the sources. Wait until your system has recognized the sources and it's added the sources. And you can see here you see an updating icon which indicates. Now this is the define module that will appear. Here define module means here we are defining what is an architecture name, and then we are also defining what are the input to the circuit, which are the inputs and which are the outputs. So how we are doing this, just I will explain a bit. Let me first okay, yeah, just pull it down. Here first I require two input numbers. What are the input numbers? A is the one variable and B is the input I will be taking. There will be input. Here you can change the architecture name if you want. What is the architecture is that in general, whenever you are seeing a VHDL code, it has a library component, then it has the entity, and then you have the architecture. In library, we will be including the prerequisite libraries. Like for example, in C language, we include stdi.h, or we are including the standard input array. Like that, for VHDL also, we need to include some of the component, some common libraries. Those we will be including. Then in entity, we are defining what are the inputs and what are the outputs. And then in architecture, we are defining the main circuit. And if you want, you can name your architecture anything. By default, it will be in behavior. And to coming on to the circuit, we have A and B as the input. And what is our output? Sum. Sum of these two will be the output, and you need to select that as output. Then, and we may also get carry. Why? Because let me explain it. Suppose let us say A is equals to 0 and B is equals to 0. Now when I sum, I get sum is equals to 0, carry is equals to 0. But when I take A is equals to 1, B is equals to 1, then it is 1 plus 1, which will be 2. But 2 in decimal is written as 1 0. That is, you have a sum of 0 and carry 1. The 1 in tens place is carried. In the MSB is carried to the carry bit. So we need the carry also. So just say out. These are the 4 inputs. Then let's click OK. Now, once you have clicked OK, in the design sources, if you will see design sources, in bracket it will show as 1. That means 1 file is added. Just you click on this icon and it will display. Just click on it and right click on it. It will open that file. Let it wait. Yeah, it is open. Now let me just undock this and make it a little bit enlarged it, so it is clear for you to understand what I will be doing. Here, these all by default it will be there. As I have already explained, that the Vivado is being used by in the industry also. So if you are using it in industry, you can need, these are all the things you need. That is, what is the company, who is the engineer, or any revisions to the file, you can add that. As I will be just doing for the purpose, I can just remove everything. Okay, just keep it here. This is the library. Then also you can even you can leave this, or you can just uncomment them. you can delete them. So this is the simple VHDL code. Here this is the library prerequisite I have explained. So how we are defining is that I will be using a keyword called library in order to say that I am going to include a library. And what library I am including? IEEE is the library that I will be including. And any statement in VHDL should end with a semicolon. Then the usage of this line is nothing but, here I am saying that in IEEE I will be using the IEEE library, for which I will be using USA as the keyword, and I am saying I will be using the IEEE library. In an IEEE library is nothing but it is a combination of variety or number of packages, libraries, functions, etc. Out of this I will be using this. This is the package I will be using, that is std_logic_1164 is the package name I will be using, and in that I will be using all of the function. That's why I kept all. If you are using any particular function, you just mention those functions here. Then we are coming on to the entity. How you write an entity is entity, then you will be defining your entity name followed by is. Next you write cap port, and in the brackets you write your input and output. Okay, and end with a semicolon, and last end architecture and half adder. Now this is the architecture we will be writing. In an architecture, first you write architecture is the keyword, then your name of the architecture of the entity name is. That is the syntax we will be following. Then we go to begin, that is we are saying the program that our architecture has begin. After begin, let us write a small code. So whatever the code we will be writing in the behavior, always it gets executed parallelly. So, and also there are different types of modeling we use to model the different circuits. So in this video I will be, as this is a basic video, I will be explaining the simplest model, that is the behavioral circuit. That is, you are just understanding the behavior. Yeah, as I already explained, this is the basic circuit. So I will be explaining in a basic manner, that is the behavior model. That is, you are just understanding the behavior of the circuit and you are using the simple logic to the circuit. So for the half adder, for sum, we are having a value like, if you want to, sum is assigned with A XOR B. How we get it is that, just first of all you write the truth table of a full half adder, and from the truth table we derive the sum, how the sum is written in Boolean expression, and then we also verify the carry. So for the half adder, sum will be A XOR B is the some Boolean expression. Here what we write is that we are defining this as the input. Now in VHDL, this is less than or equals to, this is called the assignment operator. What it does is, we are saying that first calculate this value and store that value in sum. Similarly, let me write for carry also. Carry is less than or equals to A and B. If anyone is new to this, mostly whenever they are starting with VHDL, they have a little bit idea about the digital electronics. If you have no idea, don't worry, in the future video I will be explaining it in detail. Now let us understand this. Now once you have written code, just click Ctrl S to save this code, and just let me undock this. First let me minimize this and just click on this to undock it. Okay, yeah. Now once you have written the code, now we be using the RTL analysis, that is, we open elaborated design to see if our circuit is correct. Just click on open elaborated design, just click OK in the dialog box. OK in the dialog box, you see a small dialog box like this will appear. Yeah. this is, so finally this is the circuit, this is the elaborated design. Here you can see A is the input to this AND gate and B is the input to this AND gate, and that is generating the carry. That's what we have written here, right? Yeah. And then we write sum is equal to A XOR B. That's what is happening right here. So our circuit is correct. Now let us test the circuit by running the simulation. Just click on run simulation and run behavior simulation. So it will first, it takes a little bit time. Okay. Yeah. No. Yeah. This is the window will appear. By default, as if any no value is assigned, it will be in undefined state. Now that's me force the clock. Just click force clock. Give the leading edge value as 0, trailing edge as 0, and just give this as, let's say, 75 and click OK. And similarly for B, you force a clock. That is, you are giving a pulse to this. Just click, this is 0 and this is reverse 50 and click OK. Now in order to see the simulation, just click run on. You will see window is running. Now just click on this to zoom fit this. Let it run for a little bit amount of time, like let's say 500 milliseconds. Yeah. Then just click on pause. Now let us see whether our code is working right. You can just okay, yeah. Here let me just zoom it here. Just click on this icon to zoom the window. You see the graph. So here you see A is 1, B is 1, our sum is 0, carry is 1, which means it is satisfied. This is also satisfied. Now when A is equals to 1 and B is equals to 1, sum of these will be 1 and carry, there will be no carry, so 0. That's correct. When both are 1, you have checked it. When both are 0, your sum is also 0. That's also fine. Yeah. Similarly 1 0 you are checking, 0 1 you need to check. Yeah. Yeah. So you can check your output here. Now just me let this. Yeah. Now once you have run this, now let me add the constraint file. Okay, just go to sources, just go to constraints, just click it, right click here and click add sources. Add or create the constraint and click create. Next just click on here. I have already the constraint file I have downloaded from the manufacturer. Just whatever the board you are using, just click on the go to the net and just click your board name. Either go to the manufacturer website and you can just download the .xdc file that they will provide. Just click add files. Okay. Just give me a time. Yeah. This is the thing. This is the file I will be using and click OK. Now once you added the file, just click finish. Finished? Yeah. You see a constraint file is added. Just open the constraint file. This is the constraint file that we will be using here. Just let me unlock this and just go this. Yeah. Here I have already used it for some other circuit, so it is showing those values here. So here you will see from pin number line number 12 we are defining the switcher. That is, these 3 lines will define the first switch, second switch, so on. As I will be requiring 2 switches for input, let me give them, I will just keep them as A and B, and just let me comment this. Yeah. Next I will be requiring 2 outputs also. Just let me go down. Yeah, here these are the LEDs. You have LEDs as the output and we require 2 LEDs in by default, whenever you're loading this first, you'll be written s of 2, s of 3, that will be written. You can just rechange it for your own values. That is the values you are using in your code. I'll be using the sum. Here also sum. And this is a carry. Sorry. And this is also carry. Okay. Just click save. And just unlock this. Yeah. Just click on either you can click on here, or you can just say Ctrl S to save this constraint file. Now just scroll there, go to the flow navigator, go to scroll navigator and click run synthesis. Whatever the dialog box you have, just do not change anything, click OK. Once you have clicked OK, you will observe that it is getting ready and the synthesis has begun. Synthesis state has begun. Okay. Now I will meet you again. This synthesis takes a little bit of time, again depending on your processor speed. Now I will meet you again once this synthesis is over. So once the synthesis has been completed, you get a dialog box like this appear. Here it will ask whether you want to see the synthesized design or you want to just run the implementation. What will both of you do? Let me just click open synthesis design and click OK. As this is the first video, I will be just providing the overall view. There are many other things also you can do in Vivado, which will be coming in the upward video. This is the synthesized design. What is the synthesized design is that whatever the constraint file user, based on the constraint file, the system displays the Vivado software is displaying the whole FPGA board for you to understand what is the input and what is the output. You can just zoom in and you can see the internal structures. How many flip-flops are there and how they are connected, and what are the input and output port. You can just click on see to see the interconnection. If you doesn't want to see it, you can just uncomment and you will not see the interconnection. This is a routing result. If this is highlighted, it will show how each block is connected. If you doesn't want, you can just uncomment this. I will explain this in a little bit while. Just let me zoom in and just close that. Now let us run the implemented part. That is, till now what we have synthesized the design. Now let us implement our design on the FPGA and see how it is looking. Just go down in the implementation, click run implementation, and again click OK. Now you will observe at the top here where the cursor is pointing, you see again initializing design is happening, and again you will be doing this. Now friends, in this video, as I will be recording in the room, I will be explaining up to the implementation part only. In the future video, I will be explaining how you are going to connect this to a hardware and you are seeing the output, and what the hardware is, that also I will explain in the future video. So let us wait for the initial design implementation to be completed. And friends, if at any point you are feeling discomfort or you are not able to catch up my friend, you can just pause this video, or you can run this video and you can just go back a little bit at the point where you are stuck, see my video and go further doing this video. You can always do that. And if you are still down, you are always free to comment, keep a comment in the comment section, and I will reply accordingly. Now friends, while the routing is going on, and one more thing is that friend, many of the people, yeah, okay, and if anyone is from the electronic background or from embedded systems or any related to embedded and they want any help from the projects also, you can just contact me on the mail ID and I will help you with that. You can I generally does not charge, but if it is you can consult me. Now let us wait for the implemented design to see the outputs. Now this is the window that we will get. Just got it. Yeah, this is the window we get after implementation is completed. Here, as at present, as I have not connected the hardware, I will not go to the generate the bitstream, because in generate bitstream first we need to configure the hardware, which I will explain in the future video. In this video I will be explaining this. Just click on open implemented design and click OK. Just click open implemented design and click OK. It will just say that you have opened the synthesized design. You want to close that and open it, just click yes, and let's see. Let's wait. Yeah, okay, this is a circuit. Now you may ask me, Yashwardhan, what is the difference between the synthesized design and this? This is an implemented design. If you on seeing this at a glance, you will see that there is no difference. But just let me maximize this, undock this, and just let me show you here. Now just as here you can see the routing resources has been done. Yeah, if you observe very carefully, let me zoom it a bit here. You will observe, if I just let me do it. You can observe, see, do you see some green lines? What is this green line means, man? They are connected. So whatever the VHDL code we have written, that got implemented on the Fpga. So this is the connections that are being made on the Fpga. Before they were not there, right? So that's what is the usage of Fpga. That is, by definition, it will be all will be connected, and it is just a blank slate. Whatever the circuit you want to realize, you can realize. You can just zoom it a bit more also. Let me, yeah. By zooming this, you can understand which are the LUTs that are connected and how they are being connected. Now let me show you one. Yeah, just let me go to this. Yeah, yeah. Here you can see there is different things you are connected. You have V9 and U9, and if you just keep it here, it will show what is that. By keeping this it is showing that this is the LED. Sorry, yeah, you can see it's a carry. What is the carry? Which is nothing but my output. Just let me keep it here. It is just a ground. Okay, now coming here, it is the sum output. This is U8, okay. This is nothing but the output again. Yeah, next we will you can just see the input also at wherever they are input are present. You can just see them. Inputs also, the see. Yeah, this is the B, this is carry, sorry, this is sum, and this I think is A bit. Yeah, this is the A bit. So this is the A switch input. If you see this is the B switch, and this is a sum, and this is the carry. Okay, so that's how it is happening. Just let me undock this and this. So now friends, I hope friends you have gained a good understanding about how you are going to use the Fpga, use the Vivado software in order to write a VHDL code, and how the implemented design looks. Just let me, okay, how the implemented design looks. If you have any doubt, you can always contact, you can keep in the comment section, and I will explain it, If you have still doubt, you can always mail me at the mail ID given in the description below. I hope friends you have gained a good understanding, and if anyone wants me to do any particular video in electronics also, you can comment that down below and I'll make a video on that. And also, as I'm interested in embedded system, you can, if anyone is facing any problem in any kind of embedded system also, you can comment that down below and I will explain. And I also have good knowledge in HFSS, that also you can keep it in the comment section, or you can mail me. Now thank you friends, thanks for watching friends, and I meet you again in a new video with a new concept. And before I go friends, here in this video I will explain you about how it is, as this is a simple circuit and we have only 2 inputs and 2 outputs. We have just forced the input clocks. But what happens if there are multiple inputs? Then it will be difficult for the forcing a clock for each side. So for that, how we are going to deal with that, I will be explaining in the next video. So stay tuned to the next video in this series. Thank you friends, and I will meet you again in a new video.